Hi everyone! I hope you're all doing fine. So during this COVID-19 pandemic, our lives have changed dramatically. But then, education must not stop us, for learning is a continuous process, whether you are at home or in school. So since no face-to-face allowed, the only possible way is through distance learning. I love you all in my earth science class. You all matter to me. Just do what you can and try your best to keep update in our e-learning site, for I'll be posting videos and other materials for your reference. Anyways, I am Evelyn Alegre, your teacher in Earth and Science for this semester. So I believe in you, and together we can make it. So before we will start, let's have some game. So we have here 4 picks and 1 word. So try to answer as much as you can. I will just give you 3 seconds to do it. So you have number 1, number 2, and number 3. Go. Okay, time is up. So the answer is for number 1, galaxy, for number 2, planets, and for number 3, gas. So who got the correct answer? If you get 3 points, then that is very good. Palakpakan nyo naman ang mga sarili nyo. So what do you think our lesson for today? Okay, class, buckle your seatbelt, for we are about to explore the universe. Do you think it is exciting? Yes, it is. So for our specific learning objectives, first we have describe the structure and composition of the universe. Second, explain the redshift and how it is used as a proof of an expanding universe. Third, state the different hypotheses explaining the origin of the universe. And the last, compare and contrast the different hypotheses explaining the origin of the solar system. Now, let us define few terms for a better understanding as we go through with our discussion. Okay, baryonic matter. Baryonic matter, ordinary matter, consists of protons, electrons, and neurons that comprises atoms, planets, stars, galaxies, and other bodies. Dark energy, a source of anti-gravity, a source of force that counteracts gravity and causes the universe to expand. Protostar, an early stage in the formation of star resulting from the gravitational collapse of gases. Then we have thermonuclear reaction, a nuclear fusion reaction responsible for energy produced by a star. Next, we have the main sequence star. Stars that use hydrogen atoms to form helium atoms in their cores. So outward pressure resulting from nuclear fusion is balanced by gravitational force. So what is light years? So this is referring to the distance light travel in a year, a unit of length used to measure astronomical distance. Now, you might be asked, how old is the universe? Okay, so now we are about to discuss about the theory of the universe, the origin and the formation of the universe. So the universe is at least 13.8 billion years old, and the Earth solar system is at least 4.5 to 4.8 billion years. Now we are going to discuss the structure, composition, and the age of the universe. So it is made up of 4.6% baryonic matter, 24% cold dark matter, and 71% dark energy. Okay, so try to listen carefully. Now, dark matter can explain what may be holding galaxies together for the reason that the low total mass is insufficient for gravity alone to do, while dark energy can explain the observed accelerating expansion of the universe. So the universe as we currently know, it comprises all space and time and all matter and energy in it. So we have the three most abundant gaseous elements that made up the universe. One, it is hydrogen, helium, and lithium. Okay, so try to remember these three most abundant gaseous elements: hydrogen, helium, and lithium. Now, we have the stars. The stars is the building block of galaxies, born out of clouds of gas and dust in galaxies. Instabilities within the clouds eventually results into gravitational collapse, rotation, heating up, and transformation to a protostar, the core of the future star, as thermonuclear reactions set in. Now, what is stellar interiors? So, this is just like furnaces where elements synthesize or combine, fuse together. So most stars, such as the Sun, belongs to the so-called main sequence stars. In the course of stars, hydrogen atoms are fused through thermonuclear reaction to make helium atoms. So massive main sequence stars bump up their hydrogen faster than the smaller star, like our Sun, bump up hydrogen in about 10 billion years. Okay, so we have here the illustration of the life cycle of a star. So try to look at this. So the remaining dust may end up as they are or as planets, asteroids, or other bodies in the accompanying planetary system. A galaxy is a cluster of billions of stars, and a cluster of billions of galaxies form supercluster. So in between the cluster is practically an empty space. So this organization of matter in the universe suggests that it is indeed clumpy at a certain scale, but at a large scale it appears homogeneous and isotropic. Now, based on the data, the universe is 13.8 billion years old. So, the diameter of the universe is possible infinite and should be at least 91 billion light years. Now, we will now try to explore the universe. Are you still okay? So, in 1921, Edwin Hubble announced his significant discovery of the redshift and its interpretation that the galaxies are moving away from each other. So class, try to take note of this, that the galaxies are moving away from each other, hence the evidence for an expanding universe, just as predicted by Einstein's theory of general relativity. Okay, so now he observed the spectral lines of straight made to pass through a prism are shifted through electromagnetic spectrum. So toward the band of lower frequency, thus the star or galaxy must be moving away from us. So that is why if you go out at night and try to look up the sky, Galaxies are very, very far away from us. Okay. So what is a redshift? The observation of redshift is evidence for the Big Bang theory about the origin of the universe. So scientists examining the light emitted by stars observe dark lines in the spectrum caused by different elements, such as helium in the stars being studied. So Edwin Hubble observed that the pattern of dark lines produced the light coming from distant galaxies is shifted towards the red end of the spectrum. So this redshift suggests that the distant galaxies are moving away from the Earth and support the idea of an expanding universe. So redshift occurs because of the Doppler effect, which can be observed in sound waves and electromagnetic waves. Now, what is the cosmic microwave background? Okay, cosmic background radiation is an electromagnetic radiation from the Big Bang. The discovery by chance in 1965 of the cosmic background radiation suggests that the early universe was dominated by radiation field, a field of extremely high temperature and pressure. So, in Big Bang cosmology, electromagnetic radiation as a remnant from an early stage of the universe, also known as relic radiation. So this CMB is a faint cosmic background radiation towards space. It is an important source of data on an early universe because it is used through electromagnetic radiation in the universe dating to the epoch of recombination. So what do you mean by epoch of recombination? So in cosmology, recombination, this refers to the epoch at which charged electrons and protons first became bound to form electrically neutral hydrogen. Okay, now we have to also consider the scientific thought about the non-scientific thought about the origin of the universe. So since we are talking before the scientific evidence of the origin of the universe, so now we are going to discuss about the non-scientific thought of the universe. So according to the ancient Egyptians, they believe in many gods and myths which narrate that the world arose from an infinite sea at the first rising of the sun. Okay, so next we have the Kuba people of Central Africa tell the story of a creator, God Mumba, who alone in the dark and water-covered earth felt an intense stomach pain, then vomited the stars and the moon. So can you imagine? In India, there is also a narrative that God sacrificed Purusha, the primal man, whose head, feet, eyes, and mind became the sky, earth, sun, and the moon respectively. Okay, so now we have the monotheistic religions of Judaism, Christianity, and even Islam claim that a supreme being created the universe, including man and other living organisms. So God created the universe. So what's the proof of that? It is in the Bible. So if you are a fan of reading, then try to read the book of Genesis so you can understand the beginning of the universe. Okay, So now we have to discuss the different theories about the origin of the universe. So we have the oscillating universe theory. So the oscillating universe theory is a cosmological theory model that combines the Big Bang and the Big Crunch as part of a cyclical event. So this theory speaks of a universe that has no end and has its endless process. An epoch that is equal to a complete oscillation starting from a Big Bang event through a series of different phases, after which the inflationary phase appears with a high rate. So this process, the universe reaches a stage in which the potential energy of the scalar field begins. Then a period of accelerated expansion which indicates the current age of the universe. So I hope it is clear. So in other words, the oscillating universe theory, the expansion will stop, return to its original form, then another Big Bang will occur. Okay, so let us discuss the steady state model. So this theory was developed in 1948 by Fred Hoyle, Herman Bondi, and Thomas Gold as an alternative to the Big Bang to explain the origin and expansion of the universe. So at the heart of the steady-state theory is the perfect cosmological principle. So this states that the universe is infinite in extent, infinitely old, and taken as a whole. So it is the same in all directions and at all times in the past and at all times in the future. So in other words, the universe does not evolve or change over time. So the universe has always been the same since the beginning and it remained the way forever. So try to put that in mind that this is the steady state theory. The universe has always been the same since the beginning and it remained the way forever. Okay, so now we have the Big Bang Theory. So I know you're all familiar with the Big Bang Theory as this is the current and accepted theory among all those theories that we have. So the Big Bang Theory as currently accepted theory of the origin and evolution of the universe, the Big Bang Theory postulates that 13.8 billion years ago, the universe expanded from a tiny, dense, and hot mass to its present size and much cooler state. The theory rests on two ideas. So one, general relativity, and the cosmological principle. So in Einstein's general theory of relativity, gravity is taught as distortion of space-time and no longer described by a gravitational field in contrast to the law of gravity by Isaac Newton. So general relativity, this explains the peculiarities of the orbit of the Mercury and the bending of light by the sun and has passed rigorous tests. Okay, so now we have the cosmological principles. Assumes that the universe is homogeneous and isotropic. So, when averaged over large scales, there is consistent with our current large scales. So, the image of the universe. So, but keep in mind that it is clumpy on a smaller scale. So, now, we have here the tests that prove that the Big Bang Theory withstood for the expanding universe. That is through the redshift. Second, abundance of hydrogen helium, and lithium. And the third one, the uniformly pervasive cosmic microwave background radiation, or the remnant heat from the Big Bang. So this is the Big Bang. That is why the Big Bang theory was really accepted theories among all those theory. Okay. So we have here the model of the Big Bang theory. So try to look at this for you to really understand how it is being explained from the inflation until the present. So from time zero, that is 13.8 billion years ago, until the second later, all matter and energy in the universe again existed as a hot, dense, and tiny state. So it then underwent extremely rapid exponential inflation. So the second later, after which and until seconds from time zero, conditions allow the existence of only quarks, hadrons, and leptons. So now the Big Bang nucleosynthesis took place, and it produced protons, neutrons, atomic nuclei, and the hydrogen, helium, and lithium until 20 minutes after time zero, when sufficient cooling did not allow further nucleosynthesis. So from then on until 380 years, the cooling universe entered a matter dominating the photons decoupled from matter and travel freely as it is observed today. So that is also in view with the cosmic microwave background radiation. So it is very significant progress in Big Bang cosmology that had been made since the late 1990s as a result of the advantages in telescope technology as well as the analysis of data from satellites. So such as we have the Colby. Cosmologists now have fairly precise and accurate measurements of many of the parameters of the Big Bang model. So in have an unexpectedly discovery of the expansion of the universe appears to be accelerating. So I hope it is clear about the theories of the origin of the universe because it is very much clearly explained in the theory of the Big Bang. So any questions? So if none, then we can continue to explore next. I hope you are still enjoying the travel to the universe. And now we are to explore the solar system. I hope you are still excited. Okay. So to begin with the solar system. So what is really a solar system? Of what comprises the solar system? What are in the solar system? Okay, so the solar system is the gravitationally bound system of the sun and the objects that orbit it, either directly or indirectly. The largest are the planets, with the remainder being smaller objects. The dwarf planet and the small solar system bodies of the object that orbit the sun indirectly, the moons, too, are larger than the smaller planet. Okay, so it is located at the Milky Way galaxy. It is described as a huge disk and spiral in shape, aggregation of about at least 100 billion stars and bodies. So the age of the solar system is at least 4.6 billion years. This is based on the radioactive dating and meteorites. And as far as you know, the age of the solar system is just like the age of our Mother Earth. So it revolves around the galactic center once in about 240 million years. Okay. Now, we have to start with the nebular hypothesis. So, class, remember that we are now on the solar system. Okay, so we have Immanuel Kant Perry Simon Laplace. So they are the scientists who have made this hypothesis. So independently thought of a rotating gaseous cloud that cools and contracts in the middle to form the sun and the rest into a disk that become the planets. He assumed that the mutual gravitational attraction of the particles caused them to start moving and colliding, at which point chemical forces kept them bonded together. So, as some of these aggregates became larger, they grow more rapidly, ultimately forming a planet. So, see how the planets was being formed? Okay. So, this is now the model of the nebular theory, or nebular hypothesis. So, you can see here how it started from self-gravity contracts as a gas cloud. So again, it started with a gas cloud. Then conservation of angular momentum pulls cloud into a disk. This begin to rotate. Then central mass form. So you have now the protosun. Then centrifugal force balance of gravitations forces and a ring forms. So ring forms now as of today. You can see now the planets. So this is now the illustration of the solar system. Okay, next we have to discuss about the encounter hypothesis. So according to Bapons, Sun-comet encounter that sent matter to form planet. So James Jean sun-star encounter that would have drawn from the sun matter that would condense to planet. So remember, Bapons, it is the sun-comet encounter to form a planet. For James Jean, it is the sun-star encounter to form a planet. Okay. So next we have the planetesimal hypothesis. So according to Chamberlain and Moulton's planetesimal hypothesis involving a star much bigger than the sun, passing by the sun and drove gaseous filaments from both out, which planetesimal were formed. Okay, so when you say planetesimal, it is an object formed from dust, rock, and other materials. So next we have the protoplanet hypothesis. Okay, about 4.6 billion years ago, in the Orion arm of Milky Way galaxy, a slowly rotating gas and dust cloud dominated by hydrogen and helium starts to contract due to gravity. Now, most of the materials collect in the center eventually becomes the sun. Now, what compresses the gas? Of course, it is the gravity and explosion. So, other smaller gas and dust masses shrunk into protoplanet. So, what do you mean by protoplanet? Again, it is a large planetary embryo that originated within a protoplanetary disk. Or, this is simply what is or the planet in the making. So, the planet starts in protoplanet. Okay, so take note of this. The protoplanet hypothesis theory incorporates many of the components of the nebular hypothesis, but adds some new aspects from modern knowledge of fluid and states of matter. Okay, so we have now the accretion theory. So accretion theory proposed that the sun passed through a dense interstellar cloud and emerged with a dusty, gaseous envelope that eventually became the planets. However, it cannot explain how the planets and satellites were formed. So the time required to form the planets exceeds the age of the solar system. So again, accretion is a process of growth or increase typically for gradual accumulation of layers of gases or matter. Now, we'll move on to the capture theory. So capture theory is a variation of Jeans near collision hypothesis. So in this theory, the sun drags from a near protostar a filament of material which becomes the planet. So collision between proplanets close to the sun produce the terrestrial planets. So again, do you know what are the planets belongs to the terrestrial? Okay. So those small planets like Mercury, Venus, Earth, and Mars, they belong to the terrestrial planets. And the giant planets are Neptune, Uranus, you have the Saturn and Jupiter. So they are the gas giant planets because they are big and they also have their satellites or the moons. Okay, now, so the collision of the Earth with large object produces the moon. That is why the Earth also has a moon. So this is supported by composition of the moon very similar to the Earth's mantle. So when the protosun is established as a star, its solar wind blasts hydrogen, helium, and volatiles from the inner planets to beyond. So Mars to form the gas giant, leaving behind a system we know today. So that is why our solar system comprises of planets. Small planets are the dwarf planets. We have the stars. We have the uh, okay, now, if I'm going to ask you, what makes the Earth special? Can you think of a word, a single word, or a sentence that makes our planet Earth special? Okay, so what makes Earth special? Earth has liquid water, plate tectonics, and an atmosphere that shelters it from the worst of the sun rays. But many scientists agreed our planet's most special feature might just be us. Earth is still the only world known to support life. Life was Earth's single most impressive characteristic. The fact that Earth hosts not just life, but intelligent life, makes it doubtly, or the planet's intelligent life is humanity, has even developed rockets that enable us to travel beyond the planet. So, so is there any questions? So I hope you understand our discussion today. So if there is no more question, so you can now log into your e-learning site for the activity and test. So thank you and always stay safe, stay home. See you next.